Good morning all, I am Nandhini, working as an assistant professor in SNS College of Engineering with the Department of Computer Science and Technology. Today we are going to see a video on database management system in Deadlock in DBMS. What is a deadlock? Deadlock can happen in multi-users environment where two or more transactions are running concurrently and try to access the same data in a different orders. When this happens, one transaction may hold a lock on a resource that another transaction needs, while the second transaction may hold a lock on a resource that the first transaction needs. It is nothing but if second transaction needs any help, first transaction is helping, and if the first transaction needs any help, second transaction is being helping. Both transactions are then blocked, waiting for the other release the resources they need. TBMS often use various technologies to detect and resolve deadlocks automatically. These techniques include a timeout mechanism where a transaction is forced to release its lock after a certain period of time. And deadlock detection algorithm which periodically scan the transaction log for deadlock cycles and then choose a transaction to abort to resolve the deadlock. In that next one is a deadlock avoidance. When a database is stuck in a deadlock, it is always better to avoid the deadlock rather than restarting or aborting the database. The deadlock avoidance method is suitable for smaller databases, whereas the deadlock prevention method is suitable for larger databases. One method of avoiding deadlock is using application consistent logic. In the above given example, transactions that access students and grades should always access the table in the same order. In this way, in the scenario described above, transaction T1 simply waits for transaction T2 to release the lock on grades before it begins. When transaction T2 releases the lock, transaction T1 can proceed freely. Another method for avoiding a deadlock is to apply both the row level locking mechanism and the red commitment isolation level. However, it does not guarantee to remove the deadlock completely. Next one is a deadlock deduction. Deadlock deduction: when a transaction wait indefinitely to obtain a lock, the database management system should detect whether the transaction is involved in a deadlock or not. Wait for a graph is one of the methods for detecting the deadlock situation. This graph detects the situation of a deadlock, how it can flow from which way to next way. This method is suitable for smaller databases. In this method, a graph is drawn based on the transaction and its locks on the resources. The graphs created has a closest loop or a cycle, then there is a deadlock. If it has a loop wise or a cycle wise, then this deadlock is being used. Next one is a deadlock prevention. Deadlock prevention for a larger databases, the deadlock prevention method is suitable. A deadlock can be prevented if the resources are allowed in such a way that a deadlock never occurs. The DBMS analyzes the operation whether they can create a deadlock situation or not. If they do, the transaction is never allowed to be executed. If a transaction requests resources that is locked by another transaction, then the DBMS simply checks the timestamp of both transactions, allows the older transaction to wait until the resources is being allocated. In this situation, if an DBMS deadlock pattern has been allocated, it must have certain queries to lock the either to lock the deadlock or to unlock the situation. So if a transaction requests a deadlock, it can easy to allow the situation, and if it unlocks it, it can easily detect the situation. Next one is in this deadlock situation. Wait for a graph. In this graph, if we are used to detecting the deadlock situation, so that the graph occurs with the help of waiting for a graph occurs with the help of a logic of A and B. If A tends to B or B tends to A, if A requests B and it sends to an last one of Z, if it accepts the deadlock request, it can easily deadlock can be locked. If it is not having and it is unlocking the request, then it can easily unlock that request. This graph is also known as a wait for graph, because waiting for the situation to get a request from the main person, and then it actually creates a thing that if either it is easy to unlock the situation, or if the request is being properly received, it can accept the graph. If the request is being cancelled or something happened at the time of the thing, it gets relieved at that time. So this deadlock situation is a critical one. So another method is read and commit. If a request has been accepted, it is known as a read method, and if the accept has been not requested, and rollback or a commit has been given to isolate this deadlock avoidance method. Thank you so much.